To embrace edge computing, we have good news. The 2023 AT&T Cybersecurity Insights Report provides everything you need to know to get started. In the report, we identify the common characteristics of edge computing. We found edge use cases are rapidly coming online, and we reveal how to secure edge computing. Most importantly, you'll learn how to prepare for your edge ecosystem. Get your complimentary copy of the report today. Visit securityweekly.com/ATT cybersecurity. That's securityweekly.com/ATT cybersecurity. Welcome back to Enterprise Security Weekly. Join our Discord channel to chat with us throughout the live show today. Visit securityweekly.com/Discord to receive an invite and become part of our community. Ev Kontsevoy, founder and CEO at Teleport, joins us today to talk about the pros and cons of building a security business around open source. We'll also discuss Teleport's specialty, infrastructure security. Previously, Ev founded Mailgun, an API-based email delivery service that was acquired by Rackspace. Welcome to the show, Ev.
Well, that's great to be here, and thank you for having me.
All right, and that is Ev, short for Evgeny?
Yes, it's short for Evgeny. You're right.
Evgeny. Okay. I know another Evgeny. That's the only reason I knew that. Suspected that. But yeah, thank you for coming on the show today. This is I remember when your product really made a big splash. I think maybe when the open source product first came out, and remember it seemed a lot like magic. So I guess we're starting there. Starting with the product, right? Like I remember the day it occurred to me, wait, I don't have to have SSH open to the public internet to be able to log into different resources. It just seemed like a huge game changer to me.
Yeah, that was the case at the time, because when Teleport originally was published on GitHub, and it wasn't a business since day one, it was a project that we built for ourselves. Actually, plenty of companies built their own kind of bastion infrastructure. So it was originally basically just SSH, but it evolved over time to solve all of the major problems that exist with protecting computing infrastructure at scale. So it's gone way beyond SSH since then.
Right. Now we just so would you classify this under the category of ZTNA, of Zero Trust Network Access?
Actually, I will be bold on your podcast, and I will say that Teleport created a new category. And it's not just us. There are a few other projects and companies that are in the same space. You could probably call it like infrastructure access products. Happy to talk about this in more detail, like on our view, how infrastructure access is kind of evolving, if your audience is interested.
Absolutely. Yeah. Since we started with that, we'll move to talking about the open source component later. But yeah, let's dive down that rabbit hole a bit further. What do you think separates it, makes it a new category with the latest version that, if I'm not mistaken, back in the day, we used to call it software defined perimeter, I think, and then it got the ZTNA label. And so where are we going now?
So we're going kind of back in time, but also forward at the same time. So let me clarify what I mean by this. So just imagine the world without networking, which is actually used to be true, like way back in the day. And your computing system was probably a giant computer in your basement. This is where all the kind of early operating systems came from, like Multics, if you remember that, and then Unix was built on that. So operating system was the provider for access to that computing system, right? So when you turn on a computer, you would have to authenticate, then you would get in, and you would have some kind of privileges. So authentication and authorization was always handled by the operating system, and then there was an audit component. So that's kind of how the world used to be. But then when we moved to a networking world and then to the internet, so all these concerns with secure connectivity, authentication, authorization, and audit, they got fragmented. So today, the way you authenticate into an SSH server or an RDP Windows machine or a Grafana dashboard or MongoDB or Kubernetes cluster or AWS console, they're all completely separate systems. So which leads to growing complexity and high operational overhead of configuring access. Because at the end of the day, you want like an intern in your organization to have intern level privileges for everything. So which means you need to synchronize authentication, authorization, and audit capabilities of all of these different systems to treat you as an intern. So up until now, or until very recently, organizations, they would have to buy separate products or separate solutions to solve for connectivity, authentication, authorization, and audit. So connectivity, that's the network security component. ZTNA is part of it. So that is just 1/4 of access. This is why I don't want to call Teleport like a zero trust access company, because it's only the network. But then there is also authentication. Like, how do you authenticate into, again, Grafana, Kubernetes, AWS Console, SSH, RDP, and dozens of different protocols and workloads. So to solve authentication, industry created these kind of identity companies like Okta or products like Active Directory. So they do SSO, but SSO that they provide is not tightly integrated into infrastructure. For example, we all know that it's not easy, it's not enabled by default to get into a Linux box using SSO. So then there is authorization industry. So that's a privileged access management companies that allow you to manage privileges across many different systems. Yeah, again, completely different space. And then finally, there's audit and observability. So Teleport and some other competitors that we have, we combine all of those 4 concerns, connectivity, authentication, authorization, and audit, into a single system. So now you have a single place that you need to configure to define who and when can do what across your entire global infrastructure. So Teleport gives you secure connectivity to all of your computing resources. It gives you a single login, a single sign-on. It's a place where all of your privileges are stored, and also it's a place where all the audit is connected. So it allows you to interact with your global infrastructure as if it was a single machine. That's the level of simplification that we bring with this product. So yes, we do believe it's a new category, and for now we're calling it infrastructure access. And our most notable competitor would probably be StrongDM. So they also share the same worldview.
Okay. Yeah. So some questions there to clarify. By calling it infrastructure access, I assume this is kind of focused on in-house infrastructure, on back-end stuff. So you wouldn't have the marketing team using this. It would be more like the DevOps folks, whoever's managing servers, code, workloads, stuff like that. Correct?
Absolutely. It's for technical people. So use cases, DevOps teams, engineers in general, data analysts, because they often need to get access to numerous databases that you are hosting on your infrastructure. So it's for those use cases. You're right. Okay.
And do you find yourself overlapping with like the Cloudflares and the Oktas, or are those more general IAM focused, and you're not competing with them?
So we aren't, and we are at the same time. So, like for example, Okta gives you a single sign-on, but that single sign-on by default is not really integrated with your infrastructure. So you could use Teleport to integrate Okta tightly for authenticating into all of these resources. Or you could just use Teleport, and we have all the same capabilities that Okta has, but again, optimized specifically for infrastructure use case.
Okay.
To give you an example, like we believe, so to give you an example, what I mean by optimized for infrastructure, essentially it means like optimized for scale, because solutions that are built for IT use case, which is like probably what Okta and Active Directory, they would go there. So they're not really built with this kind of scale of having millions of resources scattered in multiple data centers or cloud accounts all over the world. Because if you're dealing with that scale, things like, for example, role-based access control is no longer really working, because you end up with numerous, like huge number of groups and roles. So that's just not flexible enough. So at scale, you want to be using attribute-based access control. So when someone is trying to authenticate, like someone is trying to log in or maybe do something, you need to look at all kinds of attributes, like what is true and what is false in this particular moment in time. So that is why IT-based solutions don't really work for infrastructure really well, and that is why people are moving to Teleport.
And what about non-human stuff? What about access control for service accounts, for things like that? Are you also handling some of those use cases, or just-in-time access? Temporary, create the account for access once and then destroy it, like those kinds of use cases as well, or is it just human facing stuff?
Absolutely. In fact, our view is that in the future, and this is what the entire industry, I think, we're all working towards more and more automation. We don't believe that if you have, let's say, 1 million servers, that you should be accessing them manually via SSH. Definitely not in production. Everything needs to be done through code. Everything needs to be fully automated. So machine-to-machine access is a priority for Teleport. It's something we also support. And in fact, it's one of our design philosophies is that all Teleport capabilities, every single one of them, they're designed to be kind of orthogonal to who the user is. So which means that all of these concepts that we're introducing, like, for example, true identity and just-in-time access, so on and so forth, they're equally applicable to humans and machines. Teleport treats humans and machines exactly the same way.
Right. Yeah. The whole vending machine approach, the whole concept there that you don't need admin access 24/7, 365. How about we just give you elevated privileges right when you need them and then take them away again, right?
That's right. That's right. It's one of the kind of concepts that's now getting more popular, is that in a steady state, when nothing major is happening, you want to be able to say, nobody has access to my production environment. Mm-hmm. If that is the case, then hacking you is kind of pointless, because all of your employees, all of your engineers, by default, they don't have access to anything. So instead, the access needs to be granted when there is specific task to be accomplished. So this capability is called access requests, and it's not just Teleport. Like, there are other companies that provide that as well. Mm-hmm. So the idea is that when you need to access something, Teleport will send a message on your behalf to, like, a Slack channel saying that, hey, Ev Kontsevoy is trying to access this Kubernetes cluster or maybe this particular database, and here's the reason why he needs to access it. And then your coworkers or your manager, based on how you configure it, they have to approve. So then the access is granted, and then it's revoked automatically after I complete what I was working on.
Right. So it shifts the focus, right? Like, maybe for some attacker groups, they're like, it's just too much. We'll move on. We'll find somebody who does it old school and has password files and things like that, and shared credentials across systems and things like that. But also maybe it paints a bit of a target on you, right? That now people have to go after the system that's handing out these credentials. So I'm sure that's something you're actively thinking about as well, right?
Absolutely, since the very beginning. It's interesting that you used the word credentials 3 times in the last, 10 seconds. Right. That's really what attackers are looking for. I assume that the audience of this podcast is a bunch of smart cookies, and we all know that there are roughly 2 major kind of types of attacks. There are attacks on software vulnerabilities. Let's call them malware attacks. It's all these zero-day exploits and all of that. And the second group of attacks is like attacks on identity, that I want to pretend to be like you, so I need to steal your credentials. And identity attacks are actually way more numerous and way more successful, because if you follow the news, almost every day we're getting this announcements that this company got popped, that company got popped, so on and so forth. And it's almost always an identity attack. It's just easier than finding 0 days. And all identity attacks, they kind of follow the same pattern. First, a human mistake gets exploited. So it always begins with a human doing something they're not supposed to. And then once they get in, so they have this one compromised system. Maybe it's your laptop, or maybe it's a Bastion host, whatever. So they pivot from that one system to adjacent systems. So that is the pattern. Exploit human error, followed by a pivot to increase blast radius. And so Teleport in this case, so we came from kind of hyperscaler background. Companies like Google, Facebook, Rackspace, that's where founders and early engineers came from. And we realized that to protect infrastructure against identity attacks, you need to make your infrastructure as resilient as possible to bad behavior, to human mistakes. And so how do you do that? The perfect way to do that would be to get rid of all credentials, all forms of secrets. I'm talking about things like private keys, public keys, API keys, browser cookies, session tokens, passwords, all of these things. That's what attackers are looking to steal when someone makes a mistake. But if you design your system around the idea that there is no such thing as permanent credential, that allows you to reduce the severity of identity attacks. And that's one of the important properties of Teleport, that we call it secretless. That Teleport essentially uses physical objects for security, for defining your identity. It's a combination of your fingerprint, it's TPM chip on your laptop, it could be YubiKey with a fingerprint reader, it could be HSM on a server. So we use all of these things to establish trust between all these actors in computing. So which makes identity attacks extremely hard against Teleport, simply because for you to get access into something through Teleport, it needs to be you with your fingerprint, and it needs to be your laptop. And yes, you also need to know the password. So all of these things need to be true. So your credentials outside of your laptop and without your fingerprint, they don't really mean anything outside of Teleport.
So instead of being handed a credential that gives you access to a thing, you're given access directly to it until something happens, right? Like until a certain amount of time runs out, or until you disconnect, and then you have to go through the whole process again. So there's some kind of event that defines the end of that access, right?
That's right. That's right. So we give you access in a form of certificate that expires after a while. And the certificate is issued based on your fingerprint and your hardware, your laptop, or your YubiKey that you have.
Right, and so there's no forever certificates. In this,
no, there are no forever certificates. There are no private keys. No keys of any kinds. Like no, it's always a certificate, and it always expires. And it also, you can pin it to IP address of a client. So there are kind of multiple levels of protection. Again, physical biometric, that your finger or Face ID, then it's your TPM on your laptop, and then on top of it there is password, and also the certificate that you get at the end. It's only valid to complete a specific task.
And earlier you said it's not just SSH anymore. So I assume, you're using some kind of IPsec tunnels, something like that. You can basically tunnel any protocol, any kind of service or access that's needed between 2 points. Is that right?
Yes and no. Yes, it's not SSH anymore. We support pretty much everything you have. So this is why we say infrastructure access. But no, in a sense that we're not doing it on a network level. So Teleport built tight integrations with actual workloads. So if you're connecting to like MySQL or Postgres or MongoDB and you're getting access denied, that access denied comes from authorization engine that runs on this workload that Teleport integrates with. So we do authorization and we do audit and we do session recording on application level. That is really, really important. Or when you try to, like essentially when you go through SSO process with Teleport and you get certificates issued, those certificates work for AWS console, they work for SSH and RDP, they work for everything that's inside. But the integration, the authorization happens on the application level. So when you get access granted or access denied events, so that depends on which workload you're talking to. So Teleport is not just a proxy. It's not just a kind of zero trust exchange kind of thing. So we deeply integrate, like on Linux, we integrate with Linux kernel and using eBPF, for example. So every syscall that happens goes through Teleport.
Okay. And so, when you're logging in, when you're using resources, what is the mechanism for that? Is it, if you're integrated at the kernel level, maybe you could just SSH to a host and there's some magic you're doing behind the scenes that makes that connection happen regardless of what the network connectivity requirements are? Or is it more that there's like a SaaS portal or some kind of web portal you go to and that's where you authenticate and then you're granted different resources based on your role?
So it's the kind of question that I would love to answer with a whiteboard behind me, but I don't have one. So let me start by saying, like, Teleport is a single binary. Okay. It's written in Go. It has no dependencies. You could put it on any Unix compatible host. It could be BSD, it could be Linux, it could be Mac OS. So it's a binary. So it runs like a daemon. And again, you could start it as under systemd on Linux. You could stick it into Kubernetes if you're running Kubernetes. There are like different ways to run daemons. So that's the first thing. Then when you start it, you need to give it kind of a purpose, like what you're going to do. And there are several roles that this executable can run under. Role number one is a proxy. So you do need to establish kind of secure connectivity into these environments. So when you put proxy up, obviously it needs to have a kind of public IP address and access to a private network. So all this, like this component now only does network proxying. So then the other role you could start it, let's just call it kind of authentication or authorization server. We just call it auth service. So that thing will keep all of your permissions. It will keep the kind of database of all of your devices. It will keep database, it will keep the audit log. So that's your kind of authentication, authorization, and audit server. So you have to put it aside. And the third mode you can run this binary in is to implement protocols to integrate with this workload. So if you could put it into Linux box and say, you are now SSH, you could put it somewhere else and say, you are providing MongoDB access. So those things, they integrate on application level natively into all of these workloads. So in combination of those three roles, that's really what create, how Teleport operates. So because it's a single executable, it makes the kind of deployment very, very easy. But because you can start this executable with different parameters, allows you to kind of configure how installation works for your particular infrastructure and for your particular resource types.
Gotcha. Yeah, I think the only thing I can compare to this that I've used in the past was Zero Tier. I think that worked like it had a similar principle. It had an agent, but then you would create configurations and things like that for it. So there was some overhead there that you had to generate all that to determine what you could access with it. But I don't think they're really competing with where you're going. You're going much further with this than what they did.
Yeah, and I do want to make a very important clarification that you don't have to put Teleport on every box. Because we can integrate with OpenSSH. So if you want to continue to run SSHD on every machine, we could do that. So in fact, the most lightweight Teleport implementation is basically a single daemon running somewhere. But different organizations have different security compliance requirements, different deployment philosophies, so to speak. This is why we made this kind of split possible.
Right, yeah, it sounds very flexible. Yeah, I can see why it's popular. And yeah, so let's pivot a bit to talking about open source. As you mentioned, and I've seen this come out of other organizations as well. I forget if it was Netflix or Cloudflare, but somebody else released something that looks somewhat similar to at least the the access control component of this, or the network access component. But how did this start? At what point did you decide let's build a business around this? And what was that like, given that you could already use the product for free?
Sure. So first I'll start with something obvious that it feels kind of silly to me that why didn't we do this earlier? Because in retrospect, it's just so obvious. So here's why I think so. I'm in my 40s, and every tech company I worked at every single one, we built our own custom way of accessing our infrastructure. So it's almost like every SaaS company builds their own teleport. It's inevitable. Why? I already talked about that. It's just because there are no off-the-shelf solutions that allow you to do that. So, and that's how teleport started. So we originally had a business that was called Gravity. I'm not going to talk about that too much, but it was so we had a lot of different environments, production environments, staging environments, so on and so forth. Inside of those environments, we had combination of SSH and Postgres, and so we had Kubernetes clusters, and we needed a way to synchronize authentication and authorization across all these different resource types, but also across different environments. And then some of these environments had to go like on-premise, some of them were in the cloud, some of them would go into customer environments. So which means that you might have a customer network and they want you to remotely connect to your own software to manage it. So that's what we needed. And so we built Teleport for our own use case. And we just put it on GitHub. And originally the thought was, well, engineers love to work on code bases that are elegant and also are written in popular languages. And the best way to demonstrate that is to put your code out there and then just say, hey, look, this is our security tool. This is what it's like to work on teleports. Just go take a look. So that was, I think, the original motivation why Teleport has gone open source. Over time, we realized numerous other benefits, and I'm happy to talk about this. But the original idea was to help with recruiting.
Okay. So if you wrote it in C++, none of this would have happened, is what I'm hearing.
I think we would have gotten a lot of very talented C++ programmers.
Yeah. But yeah, okay. Yeah, maybe that's not what you want. Yeah, Go was, when you wrote this Go, I think now maybe Rust has taken that top spot, but Go was certainly popular, especially coming out of security companies.
Yes, but also remember that the original protocol that we implemented, that was SSH, and Golang has an extremely high quality standard SSH implementation. It's actually the second most popular SSH implementation after OpenSSH, I would say. Interesting.
I did not realize that. It's good to know.
Yeah, so if you want to build your own SSH server, Golang is the easiest language to do it in. And it will not only be easier, but it also will be fairly secure because that SSH stack is in production at numerous companies all over the world. So it's actively maintained.
Right, right. And so when you decided to build a business out of this, was that formula pretty much already written? There's tons of companies out there that are open source based, maybe not that many in the cybersecurity space, but certainly in the more general tech space. Did you have to do it differently than those other tech folks? Or, was it pretty much by the book in terms of like your go-to-market and, how to price and, how to monetize it, all that? Was that, were you breaking any new ground there, or is it pretty much like, most other open source based vendors have done in the past?
So I wouldn't claim that I have kind of internal knowledge or inside knowledge into how other companies have done it. So for that reason, I'm not really sure if there is a standard playbook. But the way how we transitioned from being an open source project into being a company, I could just talk about that and see how common that is. So as I said, we had another product that we were selling. It was called Gravity. That's, if you're curious, it was a kind of on-premise deployment solution. It allowed you to take your SaaS application and deploy it as a downloadable, installable package into someone else's infrastructure. So we were in the business of selling that. And we noticed that companies quite frequently would say, hey, we don't really have a lot of on-premise self-hosted needs, but the way you do security and remote access is really interesting. Can we use that for our own infrastructure? And we would get these questions like kind of over and over and over again. And then one day I just got a cold phone call that kind of pissed me off, because I think we all get pissed off when someone calls you in the middle of a meeting. And someone asked, like, hey, is that Teleport? And it kind of caught my attention. I was like, what? Like, no one ever calls me Teleport. And the person on the phone was kind of begging us to sell him a Teleport license that didn't even exist at the time. And that was this kind of final push, because we got used to hearing people saying, I would love to use Teleport for my own infrastructure. But at some point, there was this one person who was essentially telling us to shut up and take my money. That's how we became a business.
Well, that's a good way to do it, right? When you've built something, because it's the exact opposite in a lot of cases, right? Like that playbook is entirely reversed from that, where like the first time you use the product, you're already 5 to 8 sales meetings in. You've seen a lot of PowerPoint, but you don't even know if the product's going to be good, much less being able to see the code base and see how, the quality of the product and how resilient it is and how buggy it is and all those things, right?
You're right. And also you constantly see very successful, very popular open source projects deciding to monetize and then having difficulty doing so because usage does not translate to revenue. So this is why like people would tell us like, hey, I would love to use Teleport for our own infrastructure. And it's like, sure, you might be telling it just to make me feel good about myself. But show me like some real purchase intent, then I will be able to make a conclusion that you're actually seriously interested. And that's kind of what happened with Teleport, that we started to get people offering us money, even though there was not a commercial version at the time. And that made us realize that, hey, there is something there.
So it's an interesting inflection point. If you were giving other founders advice, how much of that intent do you need before you pull that trigger? Is it one really big opportunity, or did you feel like you needed at least 3 saying, hey, take my money, before you decided, okay, let's raise some funding, let's hire some people, let's quit our day jobs?
I say it's advice is cheap. It's very easy to me to take my personal limited experience and try to extrapolate to be generic enough for other people to use, but I'm not sure if it will be correct. Actually, before I even go there, I do believe that as like with any business, you have to do some kind of basic total addressable market calculation. So in case of Teleport, you're thinking, okay, so how many companies have infrastructure sitting in data centers? So the answer is huge. So then you start asking yourself, like, what pain points do they have, and what budgets are currently allocated to those pain points, and who currently that budget kind of goes to? And then you go and discover, like there's these industries, there is identity platforms like Okta, then there is a privileged access management companies like CyberArk. So you could actually go through this exercise and discover that there is an industry, or in our case, actually several, that are full of very successful companies that are solving these issues. And then you zoom into the delta, the difference between what they're doing and what your open source solution is doing. And that delta is really what you try to zoom in and see if people are ready to pay for that. And I myself, I've gotten all kinds of advice. Some people would put like a fake conversion pages, like essentially it's like, hey, we have an enterprise version coming out. Like if you're interested in paying for the product, put your email address, and then you start seeing how is that performing? Is there really demand? Should you have or not have an enterprise version? So, but I do believe that some basic market research has to be done before you begin following advice from a random guy on a security podcast.
Yeah, for sure. Yeah, if it's a super commoditized and saturated market, like you want to know that going in. You want to know if you're competing against Amazon before you quit your day job, right?
You actually nailed it. That's what I used to think about Teleport early on, that, hey, this could probably be a commodity. I cannot believe that there is nothing better out there. It's just, again, simply because every company I ever worked at, we always had SSH bastions that we built using just like SSH and creating like a proxy box. And we would create like HTTP a proxy with kind of SSO integration. It just seemed to be something that like we've all been naturally doing and not seeing an opportunity in front of our noses.
And then after you got going, does it turn into more of a normal startup? I guess because you have done another startup that I presume didn't have any open source base around it, since it was more of an email service. So did it feel like your previous company once you actually got going, where you needed a typically sized marketing function and sales function and all that to continue growing?
So from a business perspective, in terms of, like how you run the company, yes, it felt very similar, simply because, like in my opinion, Mailgun and Teleport, both of these companies were born in the same era. It's kind of, if I were to put a label on it, I would say it's the cloud. Like both of these companies are essentially cloud companies. But in terms of the mechanics of the business, Teleport is very different because it's open source. And so now we can talk about like the differences, like what is happening differently at a company whose business is built on open source versus a proprietary SaaS company. So like one difference, actually, we already mentioned a little bit earlier, because in the open source world, almost by definition, your product is downloadable. Your product is single tenant. From a technology perspective, it's really, really important. So anyone can download and run Teleport on their own. But if you were to build a SaaS offering using that creates some challenges, because essentially you need to take a single tenant code base and turn it into a massively scalable beast. At Mailgun, we didn't even think about it, because Mailgun was built in a multi-tenant fashion since day one. But Teleport exists in two forms. You can download and run it yourself, or you could set up for cloud offering. So that creates actually some very interesting engineering challenges. And our CTO would be probably a better person to talk about them.
Right.
So then you go into things like pricing and packaging, how your product is consumed. And on that side, we have a huge advantage over our proprietary competitors, because we never really have to think about the lower end of the market. Because like I see that there are college students playing with Teleport. Seed stage companies use Teleport. So there are even teenagers playing with Teleport. So all of these users, we see them as our future pipeline. So we don't need to be paranoid about being disrupted, from below, because we go all the way down to zero, because our open source solution is accessible to anyone who has any kind of computer. So that is really nice. It means I don't have to invest brain power, money, resources, engineering resources to have a kind of low tier offering. So that's really nice. And obviously all of these open source users, that's our pipeline. So I would probably say that like all of our biggest customers came from the open source, through open source adoption. So those are probably two biggest differences, but there are a few others that I also think are fairly important.
Well, I would push back on that a little bit and say you do worry about that from a different lens, though. You have to be a good open source maintainer, right? For that to
Absolutely.
Continue. Yeah. It's not fully automated. There are some really badly maintained open source projects out there, and you can't be one of them if you're hoping that that's effectively a lead funnel, right?
Absolutely, you're right. I was just trying to focus on the positive differences between running those two companies, but there are definitely challenges. Well, like the one that you mentioned, that open source does have like ongoing maintenance. That is true. You can't just ignore questions random people ask you on GitHub. Essentially, you have to be okay with essentially doing a little bit of free support for the entire world. So that's one part of it. The second one, as I already mentioned, it's the tenancy management thing. So Teleport is a single tenant thing if you go and download it, which means that it's not trivial to convert it to a multi-tenant SaaS offering. There are also concerns with kind of quality of code. So for example, I would love to just go and accept every single external contribution into our code base. But unfortunately, there is a talent shortage on the security side for skilled engineers. So you have to be, so essentially we're having really hard time getting external contributors to put into like code into Teleport for security concerns, because first of all, it's actually kind of an attack vector, right? So you might accept accidentally a backdoor, but also just the quality of code needs to be really, really high. And sometimes it almost breaks my heart. Like you might have some college students who just recently learned how to code, and they show up with a massive contribution, and you realize that 80% of it actually needs to be redone. So you need, but you also don't want to tell them just like go away. So you need to sit down and work with these people because they are your community. So all of this just adds, it's overhead. It eats into your resources, into your day, into the time you have. So yeah.
But you know what you've just done here? You've just created a talent pipeline. Like you're creating better engineers by giving them constructive feedback.
Yeah. So that actually goes back to the kind of original reason why we open sourced it. That was a great recruiting tool. But also but the flip side of it, it definitely increases the quality of your code base, because every engineer who works at Teleport, they do have this kind of thought looming over them that every time you do git push, almost 8 billion people can see what you just done. Right? So that I do believe that it's true not just for Teleport. I think it's true for most open source companies. When you realize that anybody, like anyone in the world, will be able to click on your name on GitHub or GitLab and see every single line of code you've written, that I think makes people do the better quality product.
Yeah, that you've written or Microsoft Copilot. These days, it's
that is true.
All right, Ev, this has been a great conversation. Thank you so much for joining us on Enterprise Security Weekly today.
It was a lot of fun. Thank you for having me.
All right, we'll be back in a few moments, so don't go anywhere with the weekly enterprise news.